Good afternoon. We will continue with a few more tutorial problems. Okay. We will take up an example on pole zero distribution and computation of network values from the pole zero distribution, network parameter values. First question is, you are given a circuit like this. Show that this impedance function ZS has a distribution of poles and zeros in this form. This function has the form like this. So, what would be ZS from here? R plus SL in parallel with 1 by CS. Okay. So, that gives me R plus SL into 1 by CS by R plus SL plus 1 by CS. If I multiply throughout by CS, that gives me R plus SL by S square LC plus RCS plus 1. So, this can be taken as S plus R by L into L divided by LC into S squared plus R by L S plus 1 by LC. So, you can see this is 1 by C into S plus R by L, which will be of this form S minus Z1, okay, where Z1 is minus R by L. Similarly, P1, P2 will be the corresponding roots here. The next part of the question is, for the given distribution, therefore, you have a pole here, they are not to the scale. This is root over of 111 by 2 j. This is minus root 111 by 2 j, and the real part is 1.5, 3 by 2, and the 0 is at minus 3. So, compute the values of R, L and C. R, L and C. So, could you please tell me from here what would be the values? So, I can write R by L is equal to
minus 3.
Should it be minus 3?
Plus 3, sorry.
R by L is equal to 3. Okay. Next, A square plus R by L plus 1 by LC, 1 by C, that is a constant, okay, that is separate. So, 1 by LC corresponds to what? See, it is product of P1 and P2. Here the roots are complex. So, it is minus alpha plus j beta minus alpha minus j beta. So, what will be the product? Alpha square plus beta squared. So, 1.5 squared plus this squared, is it not? So, 1 by LC, is that all right? Will be equal to 1.5 squared plus this squared is 111 by 4. So, this is 9 by 4 plus 111 by 4. So, that is 120 by 4, that is equal to 30. Okay. Anything else? Can you find out anything else? What about the addition of these two? P1 plus P2 minus alpha plus j beta and minus j beta will get cancelled. So 2 times 1.5, so 3, that will be equal to R by L. So R by L is equal to 3. Oh, that we have already got R by L from here. Okay. Can you find out anything else? Can you find out C? I have got two relations, R by L is equal to 3, 1 by LC is equal to 30. Can you find out the third one? How many poles and zeros are there? 3. Is it not? I have got only 3 values. So 3 values can give you RLC 3 different quantities. Can they? Can they give you? Let us see. This is 1.5, this is root 111 by 2. So what will be C? There is some redundancy. Can you find that? There is no uniqueness in the impedance function so far as the poles and zeros are concerned, because this K is not reflected in the pole zero distribution. Alright. So if I double the resistance, double the inductance and half the capacitance, then also I will get the same pole zero distribution. So there is no unique solution. So R and L can be expressed in terms of some C. Out of the 3, 2 of them can be expressed in terms of the third one. You cannot have a unique solution, is it not? So poles and zeros will give you only the roots relating R, L and C, but not the exact values, unless you are given something else. Now the third quantity is Z0 is 1. Z0 is 1. Now can you find out? Z0 means what? S equal to 0. So K into this one, I will get K into Z1 by P1 P2 equal to 1. Alright. So how much is K? Z1 is 3 K into 3 divided by P1 P2, product is okay. If I take here, if I put S equal to 0, will that be alright? You put that. So how much is it? If I put S equal to 0, R by L is 3. So find out K into 3 divided by, see this is my K into S plus R by L, this is 1 root divided by S square plus R by L into S plus 1 by LC, is it not? So if I put S equal to 0, K into 3 divided by 1 by LC, that is 30. 1 by LC came out to be 30. Okay. So how much is K? That is equal to 1. So K equal to 10. So if K is equal to 10, you have got C, that is equal to 1 by C. So C is equal to 1 by 10 farads. So once you have got this, so what is L? 1 by LC equal to 30. So L is equal to 1 by 30 into C equal to 1 by 30 into 110, is it not? 1 by 3 Henry. So, R is equal to 3 into L, that is 3 into 1/3 ohms, 1 ohm. Is that all right? Next we take up a problem on pole 0 distribution, and from the pole 0 distribution graphically can you compute the residues. Suppose you are given a function s plus 2 into s plus 4 divided by s into s plus 2 whole square plus 2 squared. Okay. Suppose this is the function, you may write this as s plus 2 into s plus 4 divided by s into s square plus 4s plus 8. Basically this is the function. What will be the pole 0 distribution? And suppose I want to break it up, as some k0 by s plus k1 by s plus 2 plus 2j plus some k1 star. This is a residue corresponding to a complex root. So, the corresponding residue for the other complex root will be complex conjugate of k. We will see that. So, how do you evaluate k0, k1 and k1 star graphically? So, let us draw the pole 0 distribution. 2 and 4, 2 and 4, these are the two zeros, okay, and then minus 2 plus 2j, minus 2 plus 2j, minus 2 minus 2j, these are the two zeros, and the third zero is at the origin, all right, third pole, sorry. This is the complex S plane. So, when we compute k0, the residue corresponding to this S, that is the pole at the origin, you draw vectors from other roots, that is all the zeros and poles up to that point. Then the distances of the zeros, I will write mz1, mz2, etc. Distances from different zeros up to that point divided by distances from the poles, mp1, mp2 and so on. So, how much is it? So, distance from this one is 2 into 4, and these are at angle 0. This is horizontal going from negative to positive. So, this is all having an angle 0, and how much is this? Root 2, sorry, 2 and 2, 2 root 2, 2 root 2, sorry, 2 root 2. Okay. What is the angle? 45 degrees. What is this angle? Minus 45 degrees. So, 2 root 2, 2 root 2, 45 degrees, minus 45 degrees. So, that gives me 4 into 2, 4 into 2, 1. Okay. Similarly, so this is k0, this is k0. Can you tell me what will be k1? So, the corresponding root is minus 2 minus 2j. So, minus 2 minus 2j is this one. So, draw all these vectors coming towards this point, and then What are the distances of the zeros? This is 2 and angle of minus 90 degree. Is that all right? This one is 2 root 2, because this is 2, this is 2. 2 root 2 angle minus 45 degrees. Is that all right? And then these distances, this is 2 root 2 angle 135 degrees minus, so 2 root 2 angle 135 degrees, and then this one is 2 plus 2 4, no, 4 angle minus 90 degree. Is that all right? When I come towards this, it will be 4 minus 90 degrees. So how much is it? 2 2s are 4, root 2 goes, so half, then minus 90 will get cancelled, minus 135 minus 45, so this will become plus 90. Okay, so that is half j. You can write either way. So k1 star similarly will become minus half j. Okay. If I am asked to calculate the response, this is for realizing the network, we might be interested in this. Okay. So this becomes 1 by s plus half j by s plus 2 plus 2j minus half j by s plus 2 minus 2j. Is that all right? If you are interested in knowing the impulse response, if I excited by an impulse of current, what will be the voltage like? It will be I into Zs, impulse I will give you 1, so Zs itself will be Vs. So what will be corresponding Vt? Just Laplace inverse of this. So if I am permitted to write Vt for an input of impulse of current, this one will be 1 by s, so ut plus, how much will be this? This can be written as half of, j can be written as e to the power j pi by 2. What about this? E to the power minus 2t alpha plus j beta, then e to the power j 2t, okay, minus half is common, e to the power, okay, I will write plus e to the power minus j pi by 2, e to the power minus 2t, e to the power j minus j 2t. Okay. So what will be the net value? Ut plus e to the power minus 2t can be taken out, e to the power minus 2t can be taken out. You have got e to the power j 2t plus pi by 2 plus e to the power minus j 2t plus pi by 2, is it not, divided by 2. So that gives me what? Ut plus, any mistake? E to the power minus 2t cosine 2t plus pi by 2, and how much is that? Cos theta plus pi by 2 sine, Is that all right? So, you can plot for many such functions. The tutorial problems are there, a large number of them you can try at home. Let us now go to a synthesis problem. Okay. There is a very interesting problem. A network is given, this is Z1S. The values are 1 ohm, 2 farads, 1/4 and 2 farads. Okay. You are asked to see the possibility of having another network such that if that other network Z2S is put in series with this or in parallel with this, whether I can get a net value of 1 ohm. Which one is possible and what will be the structure? Is it possible to find out another network Z2S such that if I put this Z2S in series with this, I should get 1 ohm? It may or may not be possible. Or in parallel with this, I should get 1 ohm. So, first of all, let us find out Z1S. Okay. What will be Z1S like? Could you tell me? Ladder synthesis you have seen. Can we try from there? It will be 1 by, if this is ZS, then what is admittance? 1 by ZS. It starts with 1 more, 1 plus, again impedance. This will be an impedance. If I take out 1 more, then again whatever is the balance, if I write in the impedance form, then it will be 1 by 2 farads means 1 by 2s plus 1 by 4 more plus 1 by. So, this plus this, now this is the last element left. What is admittance of this? These are basically 2 admittances, so 2s. 1 by 2s, that means 2s. So, this is another way of calculating Z1S, because you know how to do it. So, it will be 1 by 1 plus 1 by 2s plus 1 by 4 plus 2s. So, 2s into s plus 2. Okay. I can always write 2 into s plus 2. So, 2s into s plus 2, and then the numerator will be 1 by 2s. So, s plus 2 plus 2s. Check if I am all right. Is this okay? This should be 1 by. So, 1 plus, so I will invert it, 2s into s plus 2 divided by 3s plus 2. Okay. So, 1 by 3s plus 2 plus this. So, numerator will be 3s plus 2 and the denominator will be 3s plus 2 plus 2s squared plus 4s plus 3s 7s plus 2. Is that all right? 3s plus 2 divided by 2s squared plus 7s plus 2. Now, what would be Z2s? Let us see the first possibility. Z1s plus Z2s should be equal to 1. Then what should be Z2s? Case 1, if Z1s plus Z2s is possible, then Z2S will be 1 minus Z1S, and what is that? 3S plus 2 divided by 2S squared plus 7S plus 2, that's equal to 2S squared plus 7S plus 2, 2S squared plus 7S minus 3S, so 2S squared plus 4S. Okay. So if I take 2S out, will be S plus 4, 2S plus 2, S plus 2 divided by 2S squared plus 7S plus 2. So there are two real roots. Can you compute them? If I take 2 outside, S squared plus 7 by 2S plus 1. B square is greater than 4AC, so the roots are minus 7 by 2 plus minus, so 49 by 4 minus 4 divided by 2, so minus 7 by 4 plus minus 49 minus 16, so root 33 by 2. Okay. So by 2 and 2, 4. Thank you very much. So minus 7.4 means minus 1.75 plus minus root 33, you can take this to be 5.8 divided by 4. Okay. So 1.45. Okay. Now you see the distribution of roots, minus 1.75 plus 1.45, so that will be minus 0.4, 0.3. The other root is 3.2. So this will be approximately S into S plus 2 divided by S plus 0.3 into S plus 3.2. Does it sound like any of your known RL or RC network function? Does this appear to be any of those RC or RL networks? Are the poles and zeros alternately coming?
Yes.
0 pole, 0 pole. So it will be either RL or RC. Now 0 is the closest to the origin, so it will be RL network. RL network. Intuitively you can guess it has to be RL because it is an RC network, and finally it will be only real, so C part has to be compensated by L, is it not? RC network will be always giving you some R minus JX form, then the other one has to be R plus JX form. Any RL circuit you take, series, parallel, all that, for any frequency omega, its net value will be R plus Jx. So if this is R minus Jx form, this one has to be R plus Jx. So this is possible. Now you can realize this. Okay, I leave it to you as a simple exercise. You can find a Foster, Coir, Foster 1, Foster 2, Coir 1, Coir 2, any of them to realize this. Okay. Let us see the other possibility. If 1 by Z1S plus 1 by Z2S equal to 1 is possible, then 1 by Z2S will be 1 minus 1 by Z1S. Okay, that is 1 minus Z1S was 2S squared plus 7S plus 2 divided by 3S plus 2. So that will give me 3S plus 2 minus this. So obviously this is minus 2S squared, okay, minus 4S divided by 3S plus 2. you cannot realize this negative transfer function. So this is ruled out. This is not a PRF. So this cannot be realized. Another question, we will take up another interesting problem. Can you check whether s plus 2 into s plus 3 by s plus 1 into s plus 4 is positive real or not? I can write this as s squared plus 5s plus 6 divided by s squared plus 5s plus 4. Is that all right? So even ZS, only the numerator part will give me s squared plus 6 into s squared plus 4 minus 5 5s are 25 s squared. So that will give me s to the power 4 plus 4 plus 6 10 minus 10 s squared plus 24 minus 15 s squared. So if I put s equal to j omega, that will give me omega to the power 4 minus 15 s squared will become plus 15 omega squared plus 24, and this is always positive for all values of omega. Minus 15 s squared, sorry, minus 25, so total is minus 15. So that has given me 15 omega squared plus 24. This is always positive, so it is realizable. Okay, so it is a PRF. Any PRF function will be realizable, but will it be realized by RL or RC? See, pole 0 0 pole, so poles and zeros are not interlacing, so it will not be possible to realize by RL or RC. It has to be by RLC. Alright. Whenever it is a positive real function but the poles and zeros are not interlacing, then it is not possible to get the realization by RL or RC. Two element synthesis is not possible. There is another interesting question. Ys is equal to s plus 2 whole squared by s squared plus 4. Is it positive real? Now let us expand it. S to the power 4, sorry, s squared plus 4s plus 4 divided by s squared plus 4. Now s squared plus 4, if I take out, it is s squared plus 4 plus 4s by s squared plus 4. Every time I need not go for that m1 m2 minus n1 n2. If there are simple shortcuts, I will adapt that. So this is a 1 ohm resistance. This is an LC combination. It is realized also. It will be 1 ohm resistance, and how much is this? Make s tending to 0, so it will be 4s by 4, that is 1 Henry. Make s tending to infinity, it will be 4s by s squared, so 1 by 4 farad. It is a PRF. Anything that is in a realizable form with pure RLC elements is a positive real function. Is that all right? There is a very interesting problem on LC network. there is a network 1 farad, half a farad, 1 farad and 1 Henry. You see the number of elements here are 4, 1 inductance and 3 capacitances. Will it be a canonical form? 3 capacitances and 1 inductance? It is not a canonical form. Why? Because in a canonical form the difference in the type of elements will be restricted to 1, either 1 inductance, 2 capacitances or 1 capacitance. Alright. So, what will be the canonical form for this? Can you find out a canonical form for this? So, let us calculate Zs. What will be Zs? It is 1 Henry plus 1 farad. First one is 1 Henry, so S plus 1 by S, that is in parallel with 1 by 2 farad, so 2 by S. Okay. This combination is in series with 1 by S, is it not? So, let us simplify this. This is S square plus 1 by S. So, S square plus 1 by S into 2 by S divided by S squared plus 1 by S plus 2 by S. Okay. Whole thing is finally added with 1 by S. Is that okay? So, multiply throughout by S, I will get in the numerator 2 into S square plus 1 divided by 1 S will go, so S into S square plus 1 plus 2, so S squared plus 3 plus 1 by S. Okay. So, how much is this? S into S squared plus 3, okay, 2S squared, this is 2S squared plus 2 plus S squared plus 3, so that gives me 3S squared plus 5 divided by S into S square plus 3. Okay. So, what will be the canonic form? I can write 3 into S squared plus 5 by 3 divided by S into S squared plus 3. Now, you see how many elements are there? 1, 2, 3. You can realize, if you want to realize by the same type of network, alright, that is Quire synthesis. If you make so, I will write 3S square plus 5 divided by S cubed plus 3S. Can you carry out the division? So, it will give you negative values. 3 by S. So, 3S squared plus 9. So, if I subtract, I will get negative. So, this division will not be proper. So, I will have to invert it, 1 by S cubed plus 3S divided by 3S squared plus 5. Okay, 3s squared plus 5 s cubed plus 3s. Okay, so 1 by 3s plus 5 by 3s. If I subtract 4 by 3s, 3s squared plus 5. Okay, so 9 by 4 s will give me 3s squared, and then 5 4 by 3 s, so 3 how much is it, 12 by 5 s, no sorry, how much is it, 15, 4 by 15, 4 by 15 s, so that will give me 4 by 3 s. So this can be written as 1 by 1/3 s plus 1 by 9 by 4 s plus 1 by 4 by 15 s. Okay, so Zs is this, that means this is admittance. All right, so 1 by, if 1/3 s is the admittance, what is this, 1/3 s is the admittance, so it is 1/3 farad Cs. Then 9 by 4 s is the impedance, so 9 by 4 inductance, and then 4 by 15 farads. Is that all right? So this is the canonic form for this network. All right. If you are given a function with poles and zeros, okay, the location of poles and zeros are given. Say next problem. This is a 0, a pole, a 0, a pole, a 0 and a pole. Okay, so this is 2, this is 4, this is 6, this is 10. Can you write the network function? Suppose this is for Zs. An LC function is having poles and zeros at these frequencies. What will be Zs like? Some k into S, S minus 4. If it is on the imaginary axis, basically omega means j omega axis, so the value of x against omega we represent by poles and zeros, so it will be s squared plus 16, 4 squared, no, and s squared plus 100 divided by s squared plus 4, s squared plus 36. So 0 pole 0 pole 0. Okay, and if I ask you to get Foster 1 synthesis, you can do this. All right. So what will the Foster 1 structure be like? S square plus 4 will be one pole, so that will give me something like K1s by S squared plus 4. Okay, plus K2S by S square plus 36. Will there be K3S? Yes, because S squared, S to the power 5, and that is there. Will there be K4 by S? No, because there is nothing like S in the denominator. So this is all. So what will be the structure like? Corresponding to each of these factors, S by S square plus alpha or some omega squared, there is an LC parallel combination, is it not? Similarly, there will be another one for this, and thirdly it will be K3 Henry. Okay. Now suppose we give you in the Foster structure K3 equal to 2 Henries. What are the values of these? What are the values of these? Let us work out for this problem itself. How much is K1? In terms of K, K is not known. K2 will also come in terms of K. So will be K3, and there will evaluate the value of K, because K3 is known, 2 Henry, that is given. Alright. A network function whose poles and zeros are given like this and which is having a structure like this with 2 Henry inductor in series, you are asked to calculate the other element values. Alright. So K1 is, how much is K1? S squared plus 4 divided by S, S will go, make S squared plus 4 equal to 0. So this will be 12 into 96 divided by 32. Correct me if I am wrong, is that alright? Into K. Okay. So this is 3 into 12, 36K. So K is known, 2 Henries, sorry, K3. Let me calculate K2. K2 similarly S square plus 36 equal to 0. So this will be 20 into 64 divided by 32 into K, and how much is that? 40, 40K. How much is K3? K3 divide by S. If I divide by S, so they are all free from S, and then make S tending to infinity, so that this will become 0, this will become 0. Denominator becomes very heavy. So here infinity means S to the power 4 by S to the power 4. This S has already been eliminated dividing by S. So that is 1 into K. So K3 is equal to K itself, and that is equal to 2 Henries, is it not? Therefore K2 is equal to 80 and this one is 72. So 72S by S squared plus 4 will be the factor corresponding to the first set, this one. So what are the values? S tending to infinity, S tending to infinity will be giving me 72 by S, so 1 by 72 farads, okay, 1 by 72 farads, and S tending to 0 will give me 72 by 4, so 18 Henry, 18 Henry. Similarly, you can calculate the element for these, element values for this, okay. I hope all of you can do that. 80S by S squared plus 36, so that will give me 1 by 80 farad and 80 by 36, okay, that is 20 by 9 Henry. Is that okay? You may be given sometimes certain other conditions, the slope of a function. Zs, if you remember, Zs was something like this, or Ys for an LC network. Zs, Ys, these were like this, is not. It may be like this. So, if I am permitted to write the general term k1s plus k2s by a square plus omega 1 squared and so on, plus k infinity by s, I may write like this. What will be the slope at a particular frequency, say at the origin when s tends to 0, what will be the slope like for this type of a general type of function? How do I calculate that? So, each one of them you take the derivative and then put s tending to 0 or s tending to infinity, then s tending to infinity you will get this slope, okay, or this slope, s equal to 0, this is slope, alright. So, like that you can find out, we will not make s tending to infinity s equal to j omega. After taking the derivative we will put s equal to j omega, because this is against omega, and then evaluate the slopes, okay. That will always come out to be positive at any point. You can take the derivative and you can show this. This evaluated at j omega. So, if I put s equal to j omega, so how much is jx? This side is jx. So, how much is jx? Is k1 j omega plus j times k2 omega by omega 1 squared minus omega square, because s squared is minus omega square, and similar terms plus k infinity by j omega. So, it will become minus k infinity by omega into j. Now, j will be cancelling with this. So, x is given by k1 omega minus k2 omega by omega 1 squared minus omega square plus similar terms k2, k3 etc., and minus k infinity by omega. If I take the derivative with respect to omega, dx by d omega, this one will be k1. If you take the derivative of these terms, it will be all positive, you can see for yourself, and minus k infinity by omega, this will also be positive, plus k infinity by omega squared. So, all of them will give you positive terms, and hence the slope is always positive with respect to omega, okay. So, we will stop here for today. We will take up a new topic in the next class. Thank you very much. Good afternoon, friends. Today we shall be taking up graph theory, that is very much useful in networks problems. Now, let us first of all define some of the basic terminologies, and then we will see how to use these terminologies and how to use the basic network laws in a very compact form, especially when you have multi-node, say hundreds of nodes in a network, then solution of the network problems with different conditions, say voltages at different nodes may be given, some may not be given, and there are different types of elements, 4 terminal there is 2 port network elements. So, it is a complex mixture of different kinds of elements, passive and active. So, solution of such networks become very involved. We resort to graph theory in such cases. Topology, it is a branch of mathematics. It is a branch of mathematics concerned with selected properties of collections of related physical and abstract elements. All right. In network topology, we include the particular configuration of nodes and branches. The configuration of nodes and branches without regard to what elements exist in those branches. Suppose you are having an inductor, a resistor, a capacitor. For example, when we apply Kirchhoff's law, currents flowing in these elements will sum up to 0, irrespective of the type of elements that you have in the network, is it not? So, this can be used, this network topology can be used for different types of networks like water and gas mains, mechanical network, traffic flow, etc. See, network theory, this Kirchhoff's current law we can also apply to traffic flow, is it not? Number of vehicles moving towards a particular junction and number of vehicles going out at an instant, that will be summing up to 0. A graph is a set of lines we call lines or line segments known as edges. These are called edges. So, each element in a network will be represented by a line or an element. Okay, these are called edges. Then intersection of edges will be known as nodes or vertices. Intersection of edges.